Section 5.5, double angle identities. Alright. There are several of these. There are actually 3 different ones for cosine of twice an angle. So we want to list those first. So the first thing cosine of twice an angle equals is cosine squared of the single angle minus sine squared of the single angle. It also equals 1 minus 2 times sine squared of the single angle, and it equals 2 times cosine squared of the single angle minus 1. So you want to memorize those. There are 3 different versions of it. Then for sine of a double angle, it always equals 2 times sine of a single angle times cosine of a single angle. And tangent of a double angle equals 2 times tangent of the single angle divided by 1 minus tangent squared of the single angle. So I'll pause in a second and let you take notes on those. But I also want to make sure, if you could just stop for a second and watch this, that you understand what it means. Okay. What this is saying is that sine of, give me a number, an even number.
4.
4. Okay, sine of 4 degrees has to equal cosine squared of 2 degrees minus sine squared of 2 degrees. That's what it means. That it's only true if this angle right here is double this angle right here. Does that make sense? And that's for all of them. The left angle has to be twice the right angle for these identities to be true. All right, we'll pause and let you guys take some notes. Okay, so now that you've got those and you're going to start memorizing them, remember that soon you're going to have a memory quiz on all 6 of the sum and difference identities plus these 5. So that's 11 total. Very, very soon. Like as in late next week. Okay? So make sure you memorize this. Here we go. Example 1. If we know that cosine of theta equals 3/5 and that sine of theta is less than 0, we want to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So let's find the sine of 2 theta first. To do that, we're going to have to find the value of single theta. There's only one formula for sine of 2 theta, right? What is it? We know that the sine of 2 theta always equals, or the sine of 2a, always equals 2 times the sine of 1a cosine of 1a. But in this case, we're not using a's, we're using thetas. All right. So to find this value, I can plug into this side over here. I don't know this guy, but I do know this guy. Does that make sense?
Yeah.
Yes?
Do we make a triangle?
Okay. Now, I only know cosine of theta. To find sine of theta, we could make a triangle, or we could use the identity sine squared equals cosine squared equals 1. But I'm just going to make a triangle. So we'll come off to the side. And what quadrant are we in? Cosine is positive, sine is negative, so we're in quadrant 4, right? If cosine is positive and sine is negative? Yeah? Okay. We know that cosine is 3/5, so that would be x over r or y over r?
X over R.
So that would be 3/5, and this would have to be -4, because that's a 3, 4, 5 triangle. And then the sine of that is y over r, so -4/5. So now we can substitute that in. And then we just multiply all 3 of those together, and we get, let's see, -24 over 25. Does that make sense? Give me a second to think about that. And to make sure I multiply properly.
Well, if cosine is positive, it can only be 2 quadrants, 1 or 4. So.
Right. Let's find cosine of 2 theta. Cosine of 2 theta, I actually have 3 options for. We could use cosine squared minus sine squared, or we could use 2 cosine squared minus 1, or 1 minus 2 sine squared. Choose the one that you have the most given for. Does that make sense? Like, to use the first one, I would need the cosine and the sine of regular theta. But if I use the second one, which says cosine of 2a equals 2 cosine squared of a, so theta, minus 1, I only have to know the one I'm given. So you always want to choose the one that you have the given information for, if you have a choice. And for cosine, we have 3 choices.
Could you use the third one
I could, but imagine that we were starting this problem from scratch.
Okay.
You know what I mean? And I'm trying to choose from the three. I could now because I've already found sine. So I could use any of them, but I would have to go draw a triangle to do all of them except the middle one, the second one, the cosine of 2 theta equals 2 cosine squared minus 1. Make sense? Okay. So then all we do is we substitute in what we know. We know that cosine of theta is 3/5. And then we solve it. So we clean it up. And that gives me 2 times 9 over 25, which is 18 over 25, right? Minus 1, which is minus 25 over 25. And so it looks like that answer is negative 7 over 25.
Mm-hmm.
Did I do that properly?
Yes.
Okay, let's pause. Okay, so next we want to find tangent of 2 theta, and I'm just going to erase all of this and pretend like we don't know anything. We're just going to start back over. Okay, so if we started this problem and we wanted to find tangent of 2 theta, what formula would I use?
Two
Tangent
tan
of 2
A
theta
over
equals-
1 minus tan squared A.
So 2 tan A is the same in this case as 2 tan theta.
Mm-hmm.
2 tangent of theta divided by 1 minus tangent squared of theta. Okay, so in order to find tangent of 2 theta, I first have to know tangent of single theta. And the only way to find that from what I was given,
Is
I was
put
given
sine
that it was
over A.
cosine of single theta was 3/5. The only way to find that is to go either use another identity that relates them, so like one of your Pythagorean, or to go off to the side and draw a triangle. So to me, it's just as easy to draw a triangle as it is to like dig out those old identities. So we'll come over here, we'll redraw our triangle. We knew that this was 3 and this was 5, and we figured out that was negative 4. And I want the tangent of that.
So it's
negative 3 over 4.
Is it x over y or y over x?
It's y over x.
Yes, it's y over x.
So it's negative 4 over 3.
Yeah, so we have 2 times negative 4 over 3 divided by 1 minus negative 4 over 3
squared.
squared. So the top becomes negative 8/3, and the bottom becomes 1 minus,
Negative 16/9.
no, because when I square negative it becomes
Positive.
positive,
Oh,
but
yeah.
this negative is not squared, just this one. So this one is the only one
So
that's
16/9.
minus 16 over 9. So really, this was a long problem because it had so many pieces it wanted information to.
That's
So it technically, I think of this as 3 separate problems. On a quiz, this would be 3 separate problems. Okay, what can I do to fix that complex fraction?
multiply by the denominator. Yeah, on both sides.
So multiply by 9
Yep.
on top and bottom? Okay. So we're going to multiply by 9, multiply by 9, and multiply by 9. So multiply by 9 on top, that gives me, I don't really know, negative 24. And on bottom, I get 9 minus 16. So I have negative 24 divided by negative 7 for a positive 24/7. That's a nice answer. That's the tangent of 2 theta. Does anybody have a question before we pause? No? No questions?